Hello guys, today we will discuss lead code question number 1726 tuple with same product. In this question we are given an array nums which has unique positive integers. From this array nums we have to find total valid tuples that can be formed. So here any tuple is defined as it has four elements, and the first two elements, if they are multiplied, will be equal to the last two elements multiplied. So if the element is a, b, c and d, so the condition should be a into b equals to c into d. Now we have to find all the distinct number of tuples, valid tuples. Let's discuss example number 1. In the example number 1 we have given nums is equal to 2, 3, 4, 6. So in this num, if we can observe, 3 into 4 equals to 6 into 2. So I can choose one pair. I can choose a comma b as 3 and c comma d as 2 comma 6. I mean a comma b as 3 comma 4 and 2 comma 6 as c comma d. So the valid tuples can be, I can swap 2 and 3, I can swap 4 and 6, and I can also swap the pair 2 and 2 comma 3 with the pair 4 comma 6. So the answer will be 2 into 2 into 2, which is 8. Similarly, for example number 2, we have 1, 2, 4, 5, 10. So here there may be any pair which has the same product with any other pair. Let's say we have let's say we have k such pairs which have the same product. So how many tuples can be formed out of these k pairs? Okay, let's discuss this mathematically. Now if we have k pairs and we first have to choose any two pairs out of these k pairs, right? So how can that be done? Simply by using combination, PNC, permutation and combination. So the answer will be kc2. Now after we have found any two pairs, how many tuples from can be made from that one combination? The answer is simply 8, because for each tuple we can make 8 permutations. Why? Because the first two elements can be swapped, the last two elements can be also swapped, and the first two elements can be swapped with the last two elements. So gives us 2 into 2 into 2 is equal to 8. Okay, so for any product, if there are k such pairs which have the product any, let's say p, if there are 8 pairs which have product p, so the answer will be k c2 multiplied by 8. Okay, so what we are going to do here is we will find the frequency of all the products possible, frequency of pairs of all the products possible. For example, in example number 1, the frequency of product 12 is 2. Why? Because we can make two pairs, two unique pairs, which is 3 comma 4 and 2 comma 6. Okay, so this is how it goes. Now for 12 we have the frequency 2, so I can make 8 tuples. Why? Because I can choose these two pairs to make one tuple, and that one unique tuple can be permutated in 8 ways as per question. So let's try to implement this. Mm. Now we have to keep track of the frequency of all the products. Okay, so for that we will use hashing. Here I am going to use map, which maps an integer by an integer. It will be named frequency. Now I will iterate through all the possible pairs in this array nums. For that I will be using big of n square time complexity, which is allowed here because the maximum length is 1000. So n square time complexity is allowed here. Now for each I have to start from an element after that. Let's say here in the example num we are given an array 2 3 4 6. Okay, so for 2 I will check, for 3 I will count the frequency for 2 comma 3, 2 comma 4 and 2 comma 6. Similarly from 3 I will count the frequency for 3 comma 4 and 3 comma 6. Now for 4 I will count the frequency for 4 comma 6. Okay, which means I have to start this iterator j from I plus 1. Now frequency of a of I multiplied by j of I plus plus. I will just increase this frequency, a of j plus plus. Now this a is, let's rename this nums to a. Okay, we have done this. Now what we need to do is I will iterate through all the products and their frequencies. If the frequency of any product is 1, which means that we cannot make any tuple out of it. Why? Because the elements can be at max 2, but we want 4 elements. So I will just put that condition: if f is less than 2, continue. Also let's create an integer answer where we will store all the possible tuples. Okay, now the frequency is, let's say, k. I'm gonna repeat that again. Let's say frequency is k for any product. Forget that. Let's say the frequency is f, as it's shown here in the for loop. The frequency is f, so the answer will be, first we have to pick 2 pairs from the set, from the f pairs, and then permute them. So to pick 2 pairs from the set f, the total ways are fc2. Okay, the total ways are fc2, and then we have to multiply that by total number of ways we can permute that chosen tuple. Okay, which is k, which is 8 by the way. So answer plus equal to fc2 multiplied by 8. Now you might think, what have I written here? Okay, because because we have to find some formula to write here. Okay, so let's derive one formula. Okay, fc2 is basically f factorial upon 2 factorial and f minus 2 factorial. Okay, which can be also said as f into f minus 1, f minus 2 factorial, and then upon 2 factorial f minus 2 factorial. Okay, now I can cancel these out, and this 2 factorial simply means 2. So our expression becomes f into f minus 1 by 2. I can simply write this here. Also, one thing to note here, that if I am multiplying f and f minus 1 together, it will not cause an integer overflow. Why? Because the maximum allowed length here is 1000, and the maximum value for nums of I is 10 raised to the power 4. So if we say f was incredibly large, it cannot be more than 1000. So f cannot be more than, so no, give me 1 minute. So f cannot be more than 1000. Okay, which means that f into f minus 1 cannot be more than 10 raised to the power 9, which is well under 32-bit integer range, right? So it will not be causing some integer overflow, and just simply return answer in the end. Let's try to run this. Oh, I have to remove this also. This should be renamed A because that's what we have done here. Accepted. Let's submit and hope for the best. We got our solution accepted. Now to discuss time complexity, the time complexity is simply big of n square. Okay, this part is linear, this part is quadratic, so the time complexity is big of n square, and the space complexity is linear, which is this. So this was the approach to solve this, and I hope you like it, and please drop down any comment or any discussion you want to do. I would love to participate in that or answer your queries. Thank you. Bye.